Okay, let's look at one-sided continuity. Right? So here's the definition. F is called continuous on the left at x equals a if left-hand limit of f of x at a is equal to f of a. Right? Similarly, f is continuous on the right if at a if limit, I should say right hand limit at a is equal to f of a. All right, so let's look at this picture here. All right, you have a graph there. All right, at x equals a, since this is an endpoint, there's nothing on the left hand side, so we can only come from the right hand side. So this guy is f is continuous on the right, because you can see that the right hand limit and actual function value agree with each other. So this is going to be this is a continuous on the right at x equals a, right? And if you look at the right endpoint b at x equals b, there's nothing on the right of b, but we can only approach from the left hand side. So f is continuous on the left at x equals b, right? Because we can only approach from the left hand side, right? And as usual, we know that there's no breakage in the picture, so it's continuous between a and b. So f is continuous on an interval from a to b, right? All right, all combined together, so you have it's continuous on the right at endpoint a, continuous on the left at the other endpoint b, and the continuous in between. So we can say, therefore, f is continuous. Right, so we can just combine all together. So you have between a and b at a at b, so it's continuous on a closed interval from a to b. Right, so let's look at a couple of concrete example. Right, so first one, f of x is equal to square root of 4 minus x squared. All right, this is just a semicircle with radius 2, so it looks like this. All right, so you can see that this function is continuous on, all right, starting from -2 and all the way to +2. So it's continuous on negative to closed interval from -2 to 2. All right. And how about the other one? G of x is equal to square root of x. So we know how to draw square root of x, which looks like this. All right, so you can see that at x equals 0, it is continuous from the right. So this guy is continuous on, right, starting from 0, including 0. And this is continuous all the way, so it's going to be to positive infinity, right? So when you need to discuss continuity at the endpoints, we can use one-sided continuity, since we cannot talk about the regular continuity because limit doesn't exist there. All right, that's it. I hope that this was clear.